Hi, good evening everyone. So this is our 11th problem solving session for surface corrosion and control. So just a reminder on 16th April morning, the dates is not yet time is not yet confirmed. Most probably it will be 16th April morning. We'll have a revision session. So we can discuss last week's assignment. We have some doubts in the since you're here, I can uh, answer it. Try to answer your doubts first. Which are the yeah, so the seventh question. I'll take up the seventh question. We go over the theory. Okay. If you want, anyways, I'll upload this video on the YouTube. If it's better there, you can watch it later. Uh, I'll answer these questions. So the seventh question, yes, we are asked which of the following suffer interconnectional corrosion when welded. So the question is whether the post-weld solution heat treatment. So what is happening is so here let's just do these. Yeah, the first one is just the low carbon steel one. It's talking about after post heat treatment conditions. So we have following options. First is type 304 low carbon stainless steel solution, which is heat treated to this degree Celsius and then burst in water. Now, does it suffer the interconnectional corrosion? So, talking about after the heat treatment. So, since it has lower carbon, it will form lesser amount of carbide. So, it will not form as much. Uh, but we will dissolve the carbide, but there will be some rate of cooling, right? Even if you're quenching, it's not immediately going to zero. it will pass through all the um, pass through the it may pass through the carbide forming zone at when it's between 450 and 850 degrees Celsius. So that's what happens in the heat affected zone, right? They haven't explicitly mentioned like whether it will cross this zone or not. So what we're doing is welding, so it will form some heat affected zones, and then we are treating it as at this temperature and then quenching it. So again, if we pass through this zone where 850 degree and 450 degree, then some amount of at least some amount of carbide would be formed. But yeah, in case of low carbon steel, that zone would be the triple T diagram. The carbide forming zone would be much further, less we have lesser probability of carbide formation. Mhm. Again, if the cooling rate is very fast, quenching is supposed to be really fast. In that case, it shouldn't form any carbide. It dissolve everything. But it's just a matter if it crosses that 450 in this zone or not. 450 and 850. Yeah, I agree. But there is a fast method. It's always ICC things. Privilege. CP1 तो is just that. Union. Titanium dissolves it. KFC 1400. I think it's this guy. 321. If you're heat treating at 1200 degrees, it has titanium. So if you add it,
See, heating to above 1200 degrees centigrade will dissolve all carbides.
yeah.
So if we are quenching it through water, then the cooling rate will be so fast that no carbide will be formed. So it will pass the sensitization zone very quickly.
Mhm. Yeah, I agree.
Right,
Maybe.
this process now solution heat treatment is generally used to nullify the effect of
Mm-hmm.
sensitization and chromium carbide formation. So when the SS is heated to a temperature of 1200 degrees centigrade, all carbides will get dissolved, and if the cooling rate is fast, then
Yeah,
no
if it's
chromium
fast
carbide
enough, you
precipitation
won't.
will occur.
Yeah, you won't enter
So
this
I have
region.
marked the option none of the listed option is true, but that was marked as incorrect.
Mm-hmm. Um, did you ask this question on the phone?
See, I have mailed this question to the professor also, but I haven't
Okay.
received any reply. So I request you to please follow up with course instructor so that we can have better clarity on this question.
Yeah. Okay. I'll, yeah, it's how fast. Crunching is supposed to be really fast, so shouldn't enter this turbine for any reason. Let's see. Okay.
So please discuss question 8 and 9 also because
Yeah. Yep. Question. Resistance towards erosion corrosion. Here your question was why alpha plus beta is more resistant than alpha or the beta. So in erosion corrosion, what the important parameter is in this slide?
the correct option which was marked in the solution which was uploaded is option C. So alpha plus beta brass is lying in between alpha and beta brass. But during the course instruction, professor told that a two-phase
Mm-hmm.
system is having better strength, better erosion corrosion resistance as compared to the single-phase system. So alpha plus beta will be placed higher to both alpha and beta.
Yeah, that's what I believe.
And again, alpha
It
brass
should have.
contains alpha brass have more copper content than the beta brass. So higher will the copper content, more the brass will be prone to erosion corrosion. So the erosion corrosion resistance of alpha brass should be the least. Actually, it follows the reverse trend of that of de-alloying.
Mm-hmm. Definitely, we both agree that alpha plus beta will phase is harder than alpha. Probably beta also. At least this is true. So
One
this.
graph one curve was drawn by professor during the session. You can can post that also, the screenshot of that also here, where he compared de-alloying and this erosion corrosion
Yeah. Um,
with respect to the copper
this one, right?
and zinc content. No, this was one graph, another graph
There you
which was showing um, there were two scales. On one scale, professor has shown de-alloying, and on one scale, professor has shown the
go. Mhm. Yeah. DLR.
yeah, this one. Increasing zinc in brass is increasing the de-alloying, and the trend
Mhm.
followed for erosion corrosion is vice versa.
Yes. Here we are only talking about erosion corrosion. So,
So it shows erosion corrosion, and the question is asking the order for erosion corrosion resistance.
mhm. Then shouldn't it
Sol-
be like here is beta phase, here alpha plus beta, and here alpha, right?
the alpha brass have uh, what is the
Uh,
percentage content of copper in alpha brass? What is the range, and what is the percentage content of copper in beta brass?
there's a phase diagram. Okay, so here we have alpha phase, alpha plus beta, beta, and gamma. So like this one. So it's around 40, this is 80, so 60, 50% around. It's beta, around 40% is alpha, and then lithium is alpha plus beta. Just going by this, then the trend should be this one, right? And monel nickel copper we showed here, highest. Nickel is
What about alpha plus beta brass?
it should rise some in between, right? If you just go by the erosion corrosion.
It was mentioned by
Okay.
professor in the
Hmm.
lecture series. You can refer the text transcript, and you can
Okay.
search alpha plus beta brass. He has clearly mentioned that whenever there's a two phase, it will have
Okay.
strength more than any of the
Yeah, usually it
phases.
has more hardness. Two pages have more in two
He was
phases.
specifically discussing about erosion corrosion resistance.
Hmm. First word in End of 20s. Yeah, you're talking about this two phase will have better toughness, but hardness compared to that.
Beta brass contain higher zinc and less
Yeah,
copper.
yes. I'm just checking online literature whether it has higher strength. Like, is it harder than alpha plus beta? It's usually true that two phases are more.
नहीं, the sequence which is given, alpha brass will have higher erosion corrosion resistance, or beta.
Uh, so this is corrosion.
The alpha brass is having higher erosion corrosion as per the graph, as we are increasing copper
Yes,
content.
this is the
So
yeah.
it
So it
have
has
higher.
least.
So it should have least erosion.
It,
It should
it
have,
is yeah. That's
yes.
true.
So it will the option B will be more appropriate then.
Uh,
In any case,
we,
alpha brass will lie before beta
uh,
brass.
yeah, alpha will be the least between them,
Alpha
right?
will be the least. Then you please check about this alpha plus beta brass.
Alpha plus beta and beta. Yeah, I'm just checking. Usually, yeah.
There's a literature text transcript is uploaded on that portal. You can
Mhm.
refer that. In fact, this question was asked by professor to the audience which was present during the live recorded session, and
Mhm.
people have told the answer alpha blast. Then he told that being a metallurgy guy, you should know that any two-phase component will have higher corrosion resistance than single phase.
Okay. Yeah. Maybe even Professor may be aware. Like, I should just paste this link. Here it says the stronger and harder than alpha and alpha plus beta. The beta bus is actually harder and stronger than both alpha plus beta and alpha. But you're saying in the lecture he said mentioned something else. So that's
Yeah, in the lecture you have mentioned that alpha plus beta will
yeah,
have
yeah, yeah.
higher resistance than any single phase component.
Again, I would recommend you to post it on the Q&A session, or we ask the professor themselves. Yeah. Did
Yeah,
you
I
do
have
that?
posted on the Q&A session and I have asked the professor also, but I haven't
Acha,
received any reply on either of the forum.
acha. Uh, are we going to have another session, the problem doubt solving session with the professor? Do you know, or was that the last one? Okay. Yeah, I guess this is
Please discuss upon the question number 9.
ninth one. ISDL is expected for which of these alloys? So you were saying,
Here the
um,
galvanic potential difference between copper and aluminum.
you're getting out, but I get your point.
The
If you
first option
just
will be copper and then or the third option will be.
go by the electrochemical series, aluminum is the most reactive.
But aluminum easily passivate, so it
But
will.
yeah, but this alloying happens at the atomic scale, right? You're forming
But even if the
unique
alloying
cell.
is happening at atomic scale, then also this process of de-alloying or de-zincification or de-aluminification follows the galvanic concept only. So my
Yeah, but
question is
you're
that whether
saying.
passivation will happen. See, in fact, even in the case of SS, when we add chromium, the chromium is as a alloy constituent or alloy component in SS, but still it forms a passive layer over the surface of Fe. So by
Mhm.
that it
So you're asking in this copper with 20% aluminum, does the aluminum form better passivation? Then, so one thing I can say is like individual
sec-
behavior of aluminum is aluminum alone metal it does passivate, but predicting its behavior when it forms a alloy is might be different from the host metal. We can search online whether it's passivating or not.
But zincification is a prominent phenomena. The de-aluminification is not that prominent. See, if aluminum, even if in the case of SS, see, chromium
Mhm.
is an alloy component, alloy constituent, but still it is forming a chromium oxide passive layer on the surface. Uh, Alloying with copper will in fact accelerate the formation of passive layer in aluminum.
Uh, Um, um, whether, uh,
Uh, Hello.
yeah, I can hear you.
Yeah, that aluminum and zinc, that
Yeah,
leaching effect, which is the
yeah.
fastly leaching out, as aluminum is having six coordination and zinc is
Hmm.
having less coordination, whether it is easily leachable from the material.
If you just go by the electrochemical series, to see,
It is yeah, it is basing on the potential, electrochemical
yeah,
potential.
yeah. So the question is supposed to be like that. You're just supposed to compare the. I think that's what the question examiners like. We formed the question meant. So aluminum is the most reactive. Then
Okay.
you have zinc.
But
Then you have cobalt, and then you nickel. So you should have highest dealloying in case of aluminum since it has highest. Is most reactive.
okay, sir. Okay.
Yeah. But yeah, some other student asked. Uh, Aluminum does have some passivating ability, so does it
Okay.
provide? So I'm just trying to see find some literature. Maybe I'll try to answer it in the next question or post it on the. I think he has posted the question on the forum. Yeah, supposed to be like that.
Okay, sir.
Okay. Do you have specifically any other doubt? I just need to discuss all the questions anyways for the video recording and go over one by one. If you have any specific question, you can ask me now.
Sir, it is the last session or some other session will be there after this,
There will
before
be another
exam.
session. So this is the 11th week. So we'll have one more session on 16th, 15th. That will be
Okay.
before there's another assignment due, right? On 16th.
Okay. Okay.
So we can discuss that and then we'll have a revision session on 16th. So I'll go over
Mhm.
like most of the theory questions and if they post any practice question paper based on the like
Okay.
what we'll get, we can also discuss those. I do have a question paper from last year. Maybe I'll discuss
No, I
that.
don't have.
I
Okay.
have
Okay.
the access to the previous year course, so there I have access to one of the previous year question
Okay.
paper.
Okay.
So I can maybe discuss
Okay, sir.
that. That will be in the revision. So that will be on 16th April.
Okay. Okay.
There will be
Uh,
announcement made on the group.
there is no one. This is the last. I haven't seen it. Actually, I am a little bit busy in my office works. That's why I
Okay.
am not regular touch with this. That I am only listening the lectures and doing the assignments only. I am doing. I am postponing
Okay.
it because of my busy schedule.
Okay.
Mm,
Yeah,
that is
if
the
you're
thing,
able
sir.
to join, you can. I'll anyways post the recording on the YouTube. You can check it there if you have, whenever you have time. Yeah.
Yeah, yeah, sir. Yeah.
Okay.
Yeah, earlier I have this year I have registered. Earlier I have listened the classes but not registered. Then
Okay. Okay.
I have not done. This year I have registered for the exam.
Okay.
Mm.
You did the same
So
course last year too?
not last year. I have
Okay.
attended almost 2 years, 3 years back.
3 years.
I want
Okay.
to
Okay.
write that time. I am eager to write it, but I
Okay.
forgot the deadlines of
Okay. Okay. Okay.
registration. Then it is gone bad that way.
Okay. Okay.
This time I feel I will mostly I will attend the exam also.
Yeah. Yeah.
Yes, sir.
If you want, I can show you the question paper I have.
Yeah, can you please show me?
Yeah. This is what. Uh, check. Give me a second. So this is reference subjective assignment. So this was a subjective assignment given. I don't know why. This is last year. So it's going to be a pen and paper examination if you've seen the announcements. Uh, I would expect it to be subjective type, but uh, where is the announcement?
Through computer
Yes.
only?
No, it will be pen and paper exam. So, you- so this
Pen
is
and
a
paper
kind of,
exam.
yeah,
Okay.
like, yeah. And I'm not sure this is the actual exam, but if there are numericals, then expect solution something like that. There is marking scheme and all,
Okay.
like stepwise marking. Okay,
Mhm.
and if you can share, like this was the announcement for the exam. So in this list you can check, but this is a pen paper based examinations. Oh,
Okay.
okay. Yeah, you'll get the information, exam center and all later. I just keep on checking the announcement section for this. Yeah,
Okay.
okay. Yeah,
Someone is someone is typing in the chat.
yeah, yeah, for text transcript. Yeah, yeah. I saw the text transcript. It does mention alpha plus beta. This is harder than both alpha and beta. So you can, yeah, I'll check if addition of aluminum does it have passivating effect or not. Yeah. Also, if you have asked the question already on the 9, 7, 8. You can. I only see the question 7 and 9 on the portal discussion forum. You can also post the question 8 maybe. Okay, you missed it. Okay. Yeah. Okay. We can discuss this question maybe if I have some clarity. For sake of completion, I will discuss all other questions. So for lifeline attack, um, so
Sir, Cr23C6 precipitation under low cold condition also Cr23C6 precipitation occurs.
uh, precipitation will occur if you are inside this zone, like if you remember this diagram.
Sir?
If you see this diagram, you reach some temperature, and
Yeah.
if you quench it fast enough, you won't get any chromium carbide precipitate. But if it's your cooling is slow enough, you'll enter this region where your temperature is between 450 degrees Celsius and 850 or
Sir,
800 degrees Celsius. It
I,
will
I
form this.
have doubt. I
Yeah.
have doubt whether formation is at all not there. How can it will moving will be there? Formation Cr23C6 formation will not be there. Then how can it move? Because the diffusion of chromium and carbide has to come and bind on the surface of the grains.
Hmm.
In that circumstances only the intergranular corrosion will occur.
Yeah.
But here the cold working you are telling, but that diffusion, the formation of Cr23C6 phase will not
Uh-huh.
be there, na, sir. If TTT diagram,
Uh-huh.
if that he has in the that boundary only Cr23C6 will form. If it is not in the boundary, then it will not form at all.
I know if it's in this zone, this is where it will form. This boundary is where you have
Grain
maximum.
boundary, on the grain boundary, it has to go,
Yeah,
carbon
yeah,
has to migrate, chromium has to migrate, or it
yes,
will form the Cr23C6.
yes.
So if you are not at all in that phase, in that curvature, inside the curvature,
Mm-hmm.
Cr23C6 precipitation itself will not form.
No, in
So how can you tell that Cr23/6 form precipitation is forming inside the grains? That's why it is not giving the corrosion.
are you talking about a specific question or
Specific question, sixth question, na?
sixth question? Acha, sixth question. I'll open the question.
No, no, fifth question. Sorry, fifth
Fifth
question.
question.
Even I
Low
have
level
got the
cold
good
working.
answer, good only.
Let me just pull up the slide.
The question: Cr23/6 will form, and then it is in the inside the grains.
Yeah. Okay, this one. So effect of cold working and within the grain. So in high level cold work, you're promoting formation of carbide
It is
inside
there
the
in the
grain.
curve. If it is there in the curve only, Cr23C6 will form, na sir?
Uh, that's in case if you're heating it to some temperature and then cooling it. This is talking about cold working the sample.
Okay.
So here it's just referring to the two cases where you have low level cold working and high
Ah,
level cold working. So in case of high level cold working, what is being said is uh, this promotes formation of chromium carbide precipitate inside the grains. So when it forms inside the grain, it won't. You have locked the chromium kind of inside the grain, and it won't diffuse toward the grain boundary.
okay.
The chromium and even the carbon, since it's reacting with these precipitates inside the grain. So there you won't have integral IGC corrosion. Yeah. And in case of low level cold working, you're forming dislocation which provide easy pathway for carbon diffusion.
Mhm.
So that's why.
Okay.
Um, okay, in the knife line attack, what happens is uh, you're forming a weld. It's relatively thick sample you're plates you're welding. So you go through multiple passes. So in first pass, you're welding this much region. So what will happen is this region near the welded zone, this will reach above this 1214 degrees Celsius. So what happens is unstable. This knife line attack happens in stabilized grade austenite steels. Stabilized grade is where you have titanium or uh, niobium added to it to form carbides. So these carbides lock the carbon and again doesn't allow chromium carbide precipitate to form. So during your first pass, what will happen? This region will reach temperatures above 1200 degrees Celsius or 1400 degrees Celsius. This will destroy or dissolve your titanium carbide and niobium carbide precipitates. So now your carbon is no longer locked in, forming this carbide. So when you'll uh, during the next pass of the weld, now this zone is further away from this area. It won't reach this high level temperature. It will next in the second pass. It will reach 800 degree or it will cross this 800 to 450 degrees zone in the second pass. So now this since this area is in that sensitization zone, now your chromium will react with this freed up carbon. So your Cr will react with your freed up carbon, forming your chromium carbide, Cr23C6. And then this area has become sensitized toward uh, your IGC. Right. So this is what we are called knife line attack. So here you should have uh, knife line attack happens only in the stabilized grade of stainless steel. So stainless stabilized grades are 3 to 1 and 3 force them. Right? These two are two stabilized grades. So this is where right line attack happens. Okay. So again, IGC, why do we have IGC? Rate of diffusion in chromium is much less than carbon. So what is happening is nearby this region, near the grain, what will happen is chromium will diffuse toward the grain boundary, where it will react with the carbon to form carbide precipitates. It will form precipitates near inside the grain boundary. So these, since the diffusivity is low, in these two regions you have uh, depletion of chromium. So now you're, since these two regions are depleted with chromium, you won't form passive, you won't get the passivation ability which you get due to chromium. Like, why do we have chromium to the stainless steel? To, since it provides a forms of film on top, providing passivation against corrosion. And this region around here is now depleted of chromium, so passivation, no more passivation. No passive film. So now these areas are more susceptible to corrosion, so that's what is happening. So now if you have, so suppose think um, austenitic steel has higher diffusion. The chromium can easily diffuse in austenitic steel. So what will happen? Chromium inside the bulk, it will diffuse toward the depleted zone. Thus, on an average, it will again give you some passivation in this zone. So even though you'll have small amount of chromium is consumed here forming the carbide, in general, you'll still cross that passivation threshold for the austenitic steel, right? So here, intergranular corrosion for austenitic steel would not occur if chromium carbide diffusion coefficient of chromium, yes, this is true. So since if the diffusion coefficient is large enough, the chromium, you won't get this chromium depleted zone, and yeah, it won't go through IGC. This, I think this was also covered in lecture. It's not about how much chromium you have. Uh, if you have higher chromium, maybe this zone will form closer to this uh, gray, the IGC precipitate, but still it will be present somewhere. Like, it doesn't help since the diffusion of chromium is so slow. Uh, it won't be able to cover up the lack of chromium due to formation of chromium carbide. Chromium carbide is not present at the grain boundary, so yeah. Even this is true. If it's not present at the grain boundary, it will form actually. So if there is no chromium carbide, the chromium and the carbon will diffuse, forming this precipitate, and yeah, you will get this zone around it, which is incorrect. Chromium distillation does not occur at the grain boundary. Yeah, That was the reason for the intergranular corrosion, the depletion of chromium. If it doesn't happen as a grain boundary, you won't get intergranular corrosion. Sensitization of austenitic scale depends. Let me pull up the slides. Okay. Factor controlling sensitization, carbon content. So only the temperature is definitely incorrect. It's not the only one. It is one of them, but not the only one. One of the okay. Type of grain boundary. Uh, there are different type of grain boundary. High angle grain boundary, which has high energy. So these high energy ones are more susceptible to sensitization. So they are high energy sites. And you'd have more tendency to form precipitates. These would be more reactive. Type of grain boundary is correct. And carbon getters are active. So these control the activity of carbon in the alloy. So we're adding titanium or niobium, titanium. You know, these are carbon getters. They're capturing the carbon. So these stabilizing element affected. Carbon content definitely. If you have lesser carbon, will have uh, the carbon content in the steel is low, you will have lesser carbon to react at the grain boundary to form the precipitate. These three are correct. Prevention of well decay is not possible by. It is possible by solutionized heat treatment, stabilizing, yes, yes. That's what we were doing, right? Well decay. So if you're using stabilized grade stainless steel, you'll have titanium carbide or niobium carbide that will prevent formation of carbide in the other carbides in the heat affected zone. So these two are incorrect. So, and the only is if you increase the steel content, it doesn't help since you're increasing steel content, it will react more with the carbide. Sorry, the chromium, forming more carbide. So it won't prevent prevention of these. So prevention is not possible by increasing the carbon content. Fifth question I have already discussed. Which of the following statement is true for IBC? Stainless steel having similar carbon content. We have similar carbon content. This C. It's different. D. So duplex is the most resistant. Duplex is least susceptible to disease, correct? Okay. The least susceptible one so I have now cancelled out. So this cannot be right. And least susceptible, this cannot be right. This is correct. And least susceptible, so this is incorrect. Least susceptible. So among these, ferrite is the most susceptible since due to again chromium diffusion. These two are almost similar. austenite and martensite. So susceptibility, uh, ferrite is highest susceptible. Then you have austenite, austenitic steel, and then approximately equal is martensitic, and then least is duplex. The ferrite is very susceptible. It's correct. Martensite is like that susceptible. So these two are correct. Ferrite is the most susceptible one. 7th, 8th, 9th, I've already discussed. De-alloying. Mm, So, good order, but so environment definitely affects it. De-alloying increases, so more oxidizing environment, more de-alloying. Temperature of the electrolytes, that will increase your diffusion. So you are more of the in dezincification, more of the zinc ion will diffuse away. Also, temperature will increase the reactivity. De-alloying increases effective and then this see this one. So with copper zinc less than 18% zinc, there is no de-alloying. So yeah, increasing active element also increases de-alloying. And if you increase the potential, again you're increasing the uh, oxidation. You're making the surface more cathodic. All of them are correct. Which are the following statements are true for flow state corrosion? Flow state corrosion. It's not a linear relationship. First one is incorrect. Different temperature. Yes, temperature and corrosion rate, so it's not linear. Increase in chromium content. Chromium content increase. I mean, this is true. Yeah. Correct one is this one. Induction of oxygen content in supercritical water lowers the accuracy. So, role of dissolved oxygen. So, injecting some of the oxygen into the content more than this lowers the accuracy. This is happening due to formation of oxide layer on top of the surface. So that oxide layer prevents low assisted corrosion. It's preventing. It's kind of like he mentioned in the session. It's kind of like critical current density, where you're uh, providing oxygen for the reaction, so it's you're crossing that kind of crossing this barrier, so it's sufficient. With sufficient oxygen present, it will form a passivation layer and uh, prevent the flow of associated corrosion. About these three questions, I'll check. These two, though, I think this is a bit ambiguous. Like you're doing the heat treatment, then it will depend on the quenching rate. If it's fast enough, you won't enter this region. You don't cross this boundary, and you won't have any corrosion, thermal permission. But yeah, I mean this one again. If you just go by the online literature, this is true actually. Beta is the hardest phase. But it says in the lecture he mentioned something else, so that's the one because this one I'll check if uh, zinc aluminum provides any passivation. But there's a slide. De-aluminification does happen. So I'll check that too. Yeah. Any doubt other than has been discussed? If not, we can end the session here. Well, last assignment is due on 16th. Do you like that? Okay. Thank you all.
Thank you.